Working on doing regressions. We're actually looking at some college success data here. You can see this is the GPA right here, 3 years into their college career, and there's a lot of different high school grades. But we're going to be looking at SAT for math to see how good of a predictor it is for GPA. So go to regression. Just like we've done before, we'll go to linear regression. Bring that in. Now, the way that this setup actually works is our dependent variable is going to be GPA, because that's our college GPA. And then we want to see how much of a difference does SAT for math do in terms of GPA. Okay. So when we first take a look here, we'll see that we've got our ANOVA test. We've got our R squared, and then we've got our two values that we'll use to predict a particular score by. So we can go ahead and write this up again. Let's go ahead. Won't do a plot for this one. So let's go ahead and take this, copy, and then we'll put that on our Word doc again. Okay, so now this time, I'm going to do it like we did before. Let's change these to the right values. Okay, so if we look at our output, here's our ANOVA. The F value is 15.02, and then the P value is significant. So obviously, this is it is the case that SAT math scores are a good predictor of college GPA. And so we can just go ahead and write that down. So math SAT scores are a good predictor of college GPA. Oops. Based on our F value of 15.02, and then our P value of less than 0.001. I should say we should go ahead and put degrees of freedom in here too. So I'll do 1 and 222 there. Let's go ahead and italicize these. Okay, so math scores are a good predictor of college GPA based on our F value 15 and the P value under 1. Now we want to see how much. So GPA, so we go to our R squared, and that tells us that 6.3% of GPA can be founded for by math SAT scores. And then let's kind of assume that you had a let's just do 500. Math SAT score of 500 would predict a GPA of that the equation for a line is is y equals constant plus the predictor variable times x. Okay, so in this case, y is going to be equal to the constant. We can find that constant again by looking down here. Here was the constant, or the intercept. So 1.284. 1.284 plus, and then that's going to be our predictor variable, or our, and that's 0.002, and then that is going to be times 500. So when we do that, you can just use your own kind of calculator. I can actually just use this one here. Just do 1.24 plus 1.002 times 100. And so our answer is right there, 2.284. 2.28. On the end is how to do that a correlational the scatter plot that we can do for looking at these two variables, looking at math, SAT, and the GPA. So to do that, we're going to go to a slightly different place. We'll go to descriptives, click on that, descriptive statistics, and so this time we'll take GPA, bring that over, SAT on the math scores. Notice how it already gives us kind of the basics. And then we'll go from here, we'll just go to a correlation plot. Now the way that they do these correlations plots is slightly different. They give you what's called a density reading, which is the density of a particular variable. In this case, it's the GPA. And these are basically just histograms. And then we have the correlational scatter dot plot right here. So we'll just take this, and we'll copy this, then we can bring that over to our output. And for me, I still have to ask permission. Okay, this is probably going to be a little big, so we'll make this a little bit smaller. There we go. So there's our correlation plot. And we can just get rid of these. There we go. And that's it. We're all good to go.